Under 30 seconds. All right, guys. Without wasting much time, you might have been aware already. You must be aware since the beginning of the academic session. I already informed you about an opportunity to engage with the experts, who are practicing software engineers. That is the word I use, practicing software engineers, so that they can open your minds to literally what happens, especially out there in the real world. Senior high school is a different environment entirely. That level prepared you to just pass an exam to make it into the university. And so literally you would attest that most questions, they are just a bit tricky here and there. But at the tertiary level, you are more or less going to be problem solvers after you've left the four walls of this university. And so it becomes very necessary to prepare your minds, prepare you as an individual for such a space, adequately prepare you. Companies today don't really have time to recruit and train. They expect you to have some level of experience and added value, so that there is very little we have to add to you before you just sync with the institution. So in line with this, it becomes necessary to give you that opportunity to engage with a practicing software engineer in this software engineering class, get the opportunity to appreciate the scope of the course by way of knowing exactly what it entails as a software engineering course and how it applies out there in the real world and how he has been using it on regular basis. Of course, he did this before and he may repeat this again by sharing his journey through college till where he finds himself right now. And then, of course, eventually you will get the opportunity to ask some relevant questions, that will be useful to the projects you are working on, as well as, can you please mute your mic if you are not, yes. Please spare me that, okay? Make sure your mic is muted unless you want to open it up and speak up, okay? Which you have the privilege to. Even with that, you need to use the reactions features so that I'll give you the opportunity to put your word out there, one form or the other, right? So that we don't interrupt us. So he's here to engage with us. He's almost about 7 hours different from us in terms of time difference, somewhere 11, 12 p.m. where he is. And he's taking time out of his busy schedule to engage with you. I hope you find this meeting very valuable and engaging at the same time. Ladies and gentlemen, I present to you Mr. Kenny. Kenny will introduce himself and then tell you a bit about his work. So Kenny, the floor is open and it's all yours.
Awesome. Thank you so much, Mark. Hey, everyone, and glad to meet all of you. Hope you're all doing well. I'm super excited to be back talking to all of you. I think last time I was here was about a year ago, speaking to, I guess, the previous cohort. So I'll be talking about much of the same stuff. I guess none of you have heard it before, probably. So hopefully it's interesting. Let me go ahead and share my screen. Cool. Can you see my screen that I'm sharing?
Yeah, I think I can see it from here. I don't know about the rest.
Cool.
Yeah, we can see it.
Okay, perfect. Thank you.
All right,
Cool.
then
But
that's
yeah,
fine.
as Mark mentioned, I'm just going to talk about today about what software engineering is, talk a little bit about my background and what the job looks like for me. Some of the stuff I talk about today might be a little redundant with stuff that Mark has already been telling you guys in your classes. It sounds like a lot of the things he's planned for your classes are very realistic, good things that I'm pretty much going to be saying the same exact thing today. But hopefully it'll be interesting for you to get some insight into what it looks like in, I guess, the real workplace. Cool. So before we start, so first, here's what I'll be talking about today. Probably not going to take a full hour, and I want to save some time for questions at the end. So we'll see how long it goes for, but kind of flexible. I'll start by talking a little bit about my personal background. I'll give an overview of software engineering, which may be redundant for some of you who've already been taking CS classes for a while, but I'll go through it anyways. I want to spend a little bit of time talking about how school is different from working in the software engineering industry. Then I want to go into some examples of what a typical project at my work looks like. And I'll use a real example of something I worked on last year. And then at the end, I just want to talk about some variations in the software engineering industry, like different types of jobs, and then general tips and advice for all of you. And if you have questions at any point, feel free to ask, or we'll have time for questions at the end as well. Cool. So I'll go ahead and introduce myself a little bit. As I mentioned, my name is Kenny. I was born and raised here in the Bay Area of California. So this is, some of you may know this as the Silicon Valley, the San Francisco Bay Area, but I was born and raised here, went to middle school, high school here, left the Bay Area for college, which I'll talk about in a bit, but now I'm back here again for work because many of the tech and software companies are here. I guess a little tiny bit about my family background. My parents immigrated to the United States from China. So they both grew up in China and they came to the United States for graduate school, doing their graduate degrees. And after they graduated, they ended up staying here and I grew up here. I started getting, so a little bit about my CS background, I started getting into computer science in high school. So actually in my freshman year of high school, so this is, I guess, 9th grade. I don't know how grades work in your school system, but this is my freshman year of high school, so I was like 15 or 16. I joined this website development competition. So basically you compete against teams from other schools to make a website. And there was a prompt that year, which was we have to build a website for a seat reservation system, which I will show here. So basically I had to make a fake website that would let imaginary students like reserve seats for an event. So basically to build this website as a freshman in high school, I had to learn HTML, CSS, JavaScript, how databases work, basically all the technologies needed for a simple front end and back end system. And all of this I kind of just self-studied from the internet because there's so many good resources on the internet for learning these things. And that's really how I got into computer science. I just wanted to build this project and taught myself how to build those things. Like for the rest of high school, I worked on a lot of similar projects to that. I went to hackathons, built lots of websites for clubs at my school, some small local businesses who needed website help. And I even started a web development club at my high school to teach other students how to build simple websites. So for most of high school, that was my, I guess, background with computer science. After graduating high school, I went to Columbia University in New York to study computer science. So just as all of you are studying computer science in university now, in college, I learned a lot more of the CS fundamentals. Like I took courses in application development, data structures, machine learning, just the whole range of computer science courses. And while I was there, I also worked as a teaching assistant for a couple courses. Since a lot of students at the university will also work as teaching assistants for courses that they've already taken. So I ended up being a TA for an introduction to Python course, the data structures course, and then a user interface design course. And during my college years, I interned at Google for 2 summers. And I was in the ads department for both summers doing front-end development. So a lot of like JavaScript, Angular, which is a framework that we use. And yeah, that's a little bit about my college background. So currently I'm working as a full-time software engineer at Google. I've been here almost 2 years now, and I work on the YouTube ads team. So I can go into a little more detail, but maybe I'll save some of the more details if people are actually interested for the end. But the team that I work on within YouTube ads is the client infrastructure team, which is responsible for serving ads data. So I guess how you can think of it is there's a lot of different types of ads on different pages in YouTube. You have like ads in the video, little like banner ads under the video. On the home page, you'll see like photo ads where you click it and takes you to a website. So lots of different kinds of ads in YouTube. And we basically need to make sure they're all represented and served efficiently. So that's what our infrastructure does. That's what my team does. And I really enjoy being on this team because ads are just such an important part of YouTube. I know a lot of people find them annoying, but at the end of the day, they're how content creators get paid. They're how the platform stays free for users. So it's just cool being a part of such a big big product, I guess, that affects so many people around the world. And I can get into more detail about this later if people are interested. Cool, but yeah, this is a picture of the office that I work in. This is one of the Google buildings in Mountain View, which is the headquarters of Google. There's lots of buildings here, and this new building actually just opened a couple months ago. I just moved into it like 2 weeks ago. So yeah, pretty cool to be there. Also happy to talk about what it's like working there if people have questions about that later. Mark, did you have something?
Yeah, I mean, it looks so beautiful. The building looks so beautiful, in fact.
Yeah. Yeah, definitely
Wow.
nice building to work in.
I'm sure some people are eyeing the place, hoping to land there someday. Anyway, you continue.
Thanks. Cool. Yeah, so that's all I had to say about my personal background. And now I'll get into a quick overview of software engineering, which maybe will be redundant for many of you. Probably already know this stuff, but I'll give you my definition of what a software engineer is and some thoughts on that. But in my mind, a software engineer is someone who designs, codes, tests, and maintains computer software. And I really wanted to bold each of these words because each of them is a very important part of being a software engineer, not just coding and building new things. And the job of a software engineer is really to apply your computer science knowledge to real world applications. And that means a lot of different things. Because software is used in almost every industry, and no matter what you're working on, someone needs to be there to actually build the software tool. For example, at any tech company like Google or YouTube, you need software engineers to build the product because the product itself is software. But on top of that, you also need engineers to improve the product, fix issues when they come up, add new features. So it's more than just building something and then being done with it. There's constant improvements and fixes that need to be done. And there's other fields that need software engineering as well, aside from just application-based companies. The banking industry needs software engineers, automobile industry, entertainment, manufacturing, retail, healthcare, delivery. Pretty much anything you can think of these days has something to do with software engineering and needs software engineers in some capacity. As I mentioned, it's a lot more work than just coding. I'll get into this in a little more detail when I talk about an example project that I've worked on, but a lot of time is spent designing a specific feature or planning how to build new features and coordinating with other teams, like talking to the user interface team about how the feature should look, talking to the product team about what exactly this feature is supposed to be, talking to the legal team to make sure you're not violating any laws, privacy laws. So it's a lot more than just coding. And on top of that, you also need to optimize test software and maintain systems and just increase the efficiency and scale, which is very important at big companies. It's important to make sure that we can keep up with the scale of things, which I'll touch on later. So in light of all of this, the computer science knowledge that you gain from school is critical because there are so many factors to consider when developing software, and you need to kind of have a wide range of CS knowledge in order to engage in all of these conversations with your coworkers. And yeah, at the end of the day, without software engineers like us, like many of you in the future, a lot of products would be nothing more than ideas. So that is, I guess, the job of a software engineer. Next, I want to talk a little bit about school versus like what computer science looks like in school versus what software engineering in the industry looks like. And some of these I think are a little redundant because Mark actually mentioned that he planned this course for you guys where you're working in like teams of 7 with real clients. I feel like that's a pretty realistic reflection of what it's like to work as a real software engineer in industry. So I guess many of you are fortunate that you probably have experienced that already, and you maybe aren't just confined to experiencing what school, like pure school for CS is like, but I'll talk about it a little anyways. So I guess in a traditional school setting, at least in the college that I went to for computer science, a lot of the work that you do is going to involve very well-defined and isolated problems. So if you think of a typical homework assignment, maybe not this project-based course that you guys are in, but for an intro CS course or data structures course, a lot of the homework assignments you do are directly related to what you've learned in lecture. So your professor will teach you about some data structure, give you some homework assignment. Odds are that homework assignment is about exactly what you learned in the lecture. So these problems that you work with are very, very well defined, and they're isolated, meaning that once you solve that problem, you're done. Like, you can forget about it. Along with that, in school, you also have very clear solutions and very clear timelines, usually. Again, this project-based course where you're working with clients is an exception. But typically, for a given homework assignment, you have a specific solution or set of solutions that you're trying to achieve, and there's a very fixed timeline, like it needs to be due by a specific date, which is not the case in the real workplace. Typically in school, you work individually or with small teams. So is someone's microphone on? I hear a bit of static. I don't know if that's just myself. All right, I guess if you could just make sure you're muted, thank you. Cool, as I was saying, in school, you often work individually or with very small teams. Like when I was doing in college, it was usually like teams of 3 people working on homework assignments. So not really long-term projects, which again is different. And some other considerations are that when you're in school, a lot of the assignments, you start writing code from a fresh code base. Could you please mute your microphone if it is not muted? Thank you. Hello, I don't know how to. Okay, cool. Yeah, so as I was saying, in school, you pretty much write code from scratch, and you don't really have to deal with like other people's old code that you have to try to understand. And the last thing is, in school, you learn a pretty wide range of topics, which also means you'll take some CS classes in school that you won't end up using in your job, which happened to me as well. But that doesn't mean that those classes aren't worth taking. And I think it's valuable to just have a wide understanding of different CS topics. So the reason I bring up all of these is to contrast them with what working in the real workplace is like. So in the industry, requirements for a specific problem are very complex and vague, and also might change over time. So it's not like you're given a homework assignment where there's a specific problem that you need to solve, and that's that. Often I'll be given a problem that's kind of vague, like I should implement this feature, but there's no real instructions on what I'm supposed to do. So it's your job as a software engineer to figure out what questions to ask and who to ask, like which other teams you need to talk to, product managers you need to talk to, UI designers you need to talk to. So yeah, a lot more you have to navigate before you actually get to solving the problem. You need to figure out what the problem is. Along with that, you also have many different designs and solutions that are possible for solving the problem, and various metrics to look at. So it's not just there's a specific answer for the problem you need to solve. You have to come up with different ways you could solve the problem, propose them to people to see what their opinion is. And also sometimes you need to come up with your own metrics for what does it mean to have solved a problem? How will I know if this solution is adequately solving the problem? So there's no answer key, if anything. And the other thing with that is there's not always a finished state either. You might, for the most part, finish solving something, but there's always more to be done, and you need to continuously maintain that. So that's a very big difference from school. In industry, there's a lot of people you need to coordinate with, which is why I think this opportunity you have to work with a real client through this project class you're taking is such a great opportunity, because you're working in big teams of 7 people, which is very realistic. My team at work is 8 or 9 people, which is a lot different from working with 2 or 3 people. And on top of that, you need to talk to your clients, which is realistic because as engineers, we need to talk with people outside of our team to figure out how to achieve a particular project. And the final 2 things are, usually in industry, you'll be adding code to an existing code base where a lot of people have already written code. So you need to take time to make sure you understand what existing code means. So there's a lot of reading code, trying to understand it. You need to coordinate your code with other people so you avoid merge conflicts, stuff like that all of you have probably experienced or will experience. But the last thing about working in, I guess, big projects and in industry is that you learn a lot of good practices that you don't always learn in school. I feel like school you gain a lot of domain knowledge, but in industry you learn a lot more practical skills, like how to write very readable code, how to write very comprehensive tests, which personally I didn't really learn much about writing tests in school. Like I knew what tests were, but I was never really practicing that too much until I started working. And yeah, that's pretty much all I had to say about the differences in school and industry. As you can tell, when you're actually working as a software engineer, there's a lot more ambiguity that you need to navigate. And part of what you get paid to do as a software engineer is to work through those ambiguous problems. If all problems were very well defined with a clear answer, they wouldn't really need us to do our job as much. So yeah, that I think is an important thing to keep in mind. So I think we're about halfway through at this point, maybe, yeah, around that. And I want to talk about the software engineering workflow. And specifically, I want to use an example of a project that I worked on last year and talk you through all the different steps that I went through at work to achieve the project. So these are kind of the steps that I've come up with for what the typical workflow looks like. And I'll go through these each one by one using examples from the project that I worked on. Right, so the project that I worked on about a year ago is implementing these discovery ads in YouTube. And I guess I'll try to simplify some of what I talk about so we don't get into the nitty-gritty specifics of our technology because it doesn't really matter. But basically a discovery ad is a video ad. So if you're scrolling on the homepage of YouTube, you might see some videos that have this little ad symbol underneath. That video is an ad itself. So it's promoting a specific something. Like maybe it's an ad for an iPhone and there's a little iPhone, a video about iPhones playing in that video. So it's a discovery ad. It's an ad to help users discover a new product or feature. And when you click on the discovery ad, it takes you to the actual ad video. So this is a little different from traditional ads on YouTube because traditional video ads that you think of, you load some video that you want to watch. I don't know, maybe like soccer highlight video. And before that video starts, a separate ad plays. And after that ad ends, you see the video that you want. Discovery ads are different because when you click on the ad itself and you go to the video page, the main video on that page is the ad. Like there's no ad that shows first and then a video that plays after. The video that plays itself is the ad. So this was a little different from other ads across YouTube. And I was working on implementing this in our new library. So I was basically taking the old behavior and writing it in our new library. So now I'll go through each of the steps that I went through in order to do this. And the first step is always to understand the product itself. Usually the product or the feature idea is decided by maybe your manager or a product manager who's probably not even on their team. They'll basically come to your team and be like, hey, we want this feature done. We want discovery ads on YouTube done like this. Can you make it happen? And that's pretty much all the details they give you. There's not too many technical details finalized at this point. So for me, for this project, I was told by my manager, hey, we have a request from some product team that they want to launch these types of ads on YouTube, these discovery ads on YouTube. Here's all the details about what these ads look like on YouTube. Now figure out how to add it to our library. How do we structure our infrastructure to support these discovery ads? So this first step, you just understand what the product is, and that's about it. And it's very, very vague so far. So the next step, obviously, is you need to understand more details about what's being built and gather requirements. So this is a step where you have to investigate all the technical needs to successfully implement this feature. So you probably need to look through the code base, understand what systems are being affected. Is there similar projects that have been done already that you can borrow from? And just anything you can reuse or anything you can get inspiration from. Since, especially at a big company like Google or YouTube, A lot of work has been done already, and you usually don't have to write anything from scratch. You can take bits and pieces from what other people have done and pull them together to achieve what you need. So in my example, for these discovery ads, a big thing that I wanted to investigate was, where do these discovery ads show up in YouTube, and how should I structure the code to handle that? So if you have used YouTube before, there's actually several different pages on YouTube. You might not think of them as pages, but internally we consider them different pages. We have the home page, which is when you first load YouTube, all the recommended videos. We have the search page, which is when you use the search bar in YouTube, and then it shows you results related to your search. And then we have the watch page, which is the actual page where you watch a video. And if you scroll down, there's related videos there. The thing with a discovery ad is that it could show up on any of these three pages. It could be on your home page, it could be on the search page, or when you're watching a video, the discovery ad could appear below the video as you're scrolling through related videos. So this was something that I had to understand in more detail. And this was important to understand. I won't get into too much details, but each of these pages has its own RPC call. So you can think of this as the user, when they load the page, a function is called to actually get all the information for that page. And each of these pages has a separate function to do that. However, the discovery ad itself looks the same on all three pages. Then it's in a different spot, but it looks the same. So one thing that I was trying to keep in mind was, or actually I'll get to that in the next step, but that was an important thing to keep in mind, that across all these pages, even though they're different pages, the ad looks the same and the behavior is the same. That is, when you click on the ad, it'll take you to the ad video, and there'll be some ad info around it. So this bottom photo here actually shows you what happens if you click on a discovery ad. They'll play the ad video, and then there'll be this little banner under the video that we call a companion. It's like the companion to the video with information about that ad. So after you gather requirements, probably the most important part of the process is coming up with the engineering design. So during this phase, you come up with a detailed outline or a document of what the code will look like, how the code will be structured. And this part is tricky because there's a lot of different possibilities for what you could do. So usually at least what we do is we'll outline all the different possibilities. Here's the first approach for achieving this result. Here's the pros and cons of this approach. Here's the second approach. Here's the pros and cons. And then it's a lot easier for your teammates to give you feedback. Hey, this approach looks good, but this con that you listed, it's just a deal breaker. We can't do that. So let's go with this option. So it's good for discussion. And since code like this affects many different systems, it affects the homepage, the watch page, and each of those have their own teams that manage those servers. We need to get approval from those teams as well. So it's important to have a design that lots of people can look at. And a lot of my time at work is spent coming up with these designs, understanding the code and proposing things, not actually coding yet. After you come up with the design, obviously you can delegate the work and prioritize it, but the design of it is a big part of it. So in my example for these discovery ads, after I realized that these discovery ads look and behave the same across these different pages, across these different RPC calls, one of the proposals I came up with was, instead of handling them differently on each page, let's have a unified library, just a unified ads library to handle all ads rendering. So no matter what page is called, they'll call the same library, and that library will output the same ad. And then that way we can just write the ads code in one place and then make all three RPCs call that. So it's basically shared. So we don't have to rewrite it 3 times. So I guess that's a simplified version of what my team does. We maintain this unified ads library. But yeah, that's a very important part of the design. After the design is finalized is when you can start coding. And personally, I think coding is a lot easier than designing, because when you're designing it, that's when you're thinking about all the hard decisions. How should I structure the code? What should I be doing? Why should I do that? Once you start coding, all those decisions are already made. So you pretty much just look at the design and then rewrite it in code. So I feel like this step is a lot simpler for the most part. The one tricky thing that comes up when you're coding is just due to the fact that designing and coding is a very iterative process. So sometimes I'll be coding something and I'll realize, oh shoot, I forgot to consider a specific thing. Then you'll have to go back design some more details for whatever you forgot, get that approved, and then you can go back and finish coding it. So it's a very back and forth process. It's not linear. You'll design, code, realize that you're stuck on something, redesign something, go back and code. Very iterative process. So one example using the discovery ads is as I was implementing this feature, I realized that one thing we forgot to consider was that within discovery ads, there's actually two different ad types. The discovery ad could be an app install ad, which means an ad to encourage the user to install an app. So when you click install, it will take you to the App Store. Or it could be an action ad, which is when you click the button for an action ad, it'll take you to a website for that specific ad. So app and action ads then are different. Even though they're both discovery ads, there's some differences in behavior, which I didn't consider when I was initially designing. So I had to go back and redesign how can we handle that in our code. And I guess a simplified version for how we handle that is maybe some Boolean in the data structure that indicates, is this ad for an app or for an action? And then depending on that, we can have different text in the button. If you look at the app ad, we have this rating and then the price of the ad. But for an action ad, obviously there's no rating for a website. So these are some differences in behavior that we had to go back and reconsider. Another big part of coding at big companies, or I guess at any company, is that you need to review other people's code as they implement stuff that might not be related to your project exactly, but if it affects the same code base, it could affect yours. So like, for example, at work, I can't even submit any code unless someone reviews it and approves it. And that's just our way of making sure that people don't write broken code, because someone's always checking for you. So we're close to wrapping up this workflow. After your code is implemented, actually, while you're implementing your code, you'll write tests to make sure your code works. I'll kind of skim through this part quickly, but there's a lot of different tests that we write, but the idea behind them is all the same. We want to try the different edge cases to break the feature. And it's better if we find ways to break it and then fix those, rather than the users find a way to break them and then they actually break when they're using it. Some examples of tests we use are unit tests, which test like a specific subunit of code. So for example, a unit test might test that the button in this ad has the right text, whereas an end-to-end test tests the whole system. Like when you load the homepage, is the entire ad there? So you can just think of it as a bigger test, and we write both of these tests. Another way we test code is we run live traffic experiments and look at metrics. So what this means is we might implement a new feature, and initially when we're writing the code, obviously users won't be seeing this code. We're guarding the code. It's not released to anyone. Once it's done, we'll release it to like 1% of users around the world, maybe 0.1% of users around the world, which is millions of users. We'll look at the metrics for that and be like, for that 0.1%, how many of them saw this ad? How many of them had errors? If we see a lot of errors for 0.1% of users, then we know we shouldn't release it to 100% of users, because it's going to just be terrible. So this is a way for us to catch issues before we fully roll them out to users around the world. And you do catch a lot of errors like this. So I think it's good that we do this. And the last part, this is the last step. Once you're done testing, once you've released the code to 100% of users around the world, you need to maintain and improve the code. So you kind of need to continue to look at the metrics, see if maybe one day there's a lot of errors. You'll have to go in and investigate, fix bugs as they come up, because it could come up. We actually have something called on-call, which is basically a rotation-based thing, where each person on our team will take turns being the person who's on call. And if there's any big issues that happen to ads that week, they'll get a notification on their phone. Could be any time of the day, maybe 3 a.m. at night. You'll have to wake up, investigate it a little bit, and just figure out who within the company needs to help you solve this problem. So this is basically our way of investigating issues immediately when they happen. And this is a very big part of being a software engineer. It's not just implementing features, but maintaining them as well. So that's all I had to say about my workflow with this example project for discovery ads. Before we wrap up, maybe the next 5-10 minutes, I just want to quickly skim through different types of software engineering roles and then give some advice to all of you as students. So very quickly, just looking at the software engineering world, first of all, there's a lot of different types of software engineers. You have front-end engineers who are probably making the appearance of websites or of apps. You have back-end engineers who probably work more closely with databases, or an infrastructure team like the one I work on is probably more back-end. You have mobile developers who make mobile apps, game developers who design video games, machine learning engineers who create machine learning models to predict things for a specific product or company. DevOps or development, like operations, you're probably working on internal tools to help a company, help other engineers at your company develop more quickly, like maybe a tool to help engineers debug stuff. QA, so your focus is going to be on testing and making sure things don't break. And then security would be another one. Other factors to consider aside from the role, one is your industry, which I touched on earlier, a lot of different industries that need software engineers. Another one is the size of your company. Like, it's a very big difference working for Google, which has hundreds of thousands of employees, versus a startup, which might have 7 employees. Both are very different experiences, and there's no really right or wrong way to figure out what you like besides experiencing it yourself and figure out your personal preferences. And then the other thing to consider is the type of product that your company is working on. I love working on YouTube because it's a very user-facing product. People use YouTube every day, like myself. You might also work on a company that develops internal tools or enterprise software. For example, maybe Workday is an example of an enterprise software. It's a platform that lets employers manage their employees, and employees can see like how many vacation days they have. So this is a product that like general public will never use, but companies will use. So these are all different products that you might end up working for, and it's fine to have preferences about what you like or dislike. Cool. So for this last segment today, I just want to quickly go through some of my tips and advice from you. And I think a lot of these will align with the advice that Mark has been telling you guys as well. So hopefully it's not too redundant, but it reinforces some of what he's been saying. The first and biggest piece of advice is the importance of building personal projects. And I cannot emphasize this enough. It's very, very important to have a personal, not even a portfolio really, just like a resume with some of the projects that you've built on it. If you look at my resume here on the right, this is like a sample resume that I maybe like a year or two ago. Most software engineering resumes look pretty similar. You have an education section, which all of you will have as well. Like a very brief skills section where you just outlined here are the technologies I'm familiar with. And the 2 most important sections are your work experience and your projects. And the difficulty for students, myself included when I was a student, is you don't have much work experience, which makes sense because you haven't even interned yet for the most part. So what you need to do is rely on projects to showcase your technical abilities. So for a lot of students in school, your resume will be education, maybe like one small work thing, and then mostly projects that you've worked on, because it's important to show your potential employer that you're able to actually build things with your technical skills. Some other benefits of working on personal projects is it's a great way to learn new technologies. And it's very useful to get used to self-learning. Like if you want to work on a mobile app and you've never done a mobile app before, I think that's a great personal project. It might not be an amazing mobile app your first time building it, but it doesn't need to be like something that people download in the app store, something that makes money. It doesn't have to be anything like new or crazy. It can be something that already exists and you're just learning how to rebuild that. And that's a valid personal project. The value of kind of self-learning with trying different projects is that when you get into the workplace, you're going to need to learn how to learn things on your own. For example, my current job, I code in C++, which I pretty much never really did before. I learned C when I was taking CS courses in school, but not C++. So when I got on the job, my first 2 weeks of work, I was just going through C++ tutorials, trying to learn that so I could actually contribute to my team. So self-learning is very important once you get to the workplace. And especially at companies like Google, they don't even really care what languages you know. Like they don't care if you know Java or Python, C++. They don't care what language you interview in, because once you get into the company, depending on what team you'll be on, they're going to ask you to learn whatever they use, and you'll be expected to learn it. So just self-learning is a very, very valuable skill. Last thing I have to say is, while you're in school, I would just focus, along with like making personal projects, just focus on having strong fundamentals. In college, some classes are needed for all software engineers, while others are a good way to explore a specific subject area. And I think that both are valuable to take. Like if I think back to college, when I was interviewing for tech jobs, the only course that really helped me for that was data structures. Like if that's all I cared about, I could have taken data structures and just not taken any other CS class. And I probably would have had enough knowledge to do interviews, because the interviews just test data structures. But there's so much benefit you get in college from taking those other courses, like taking a machine learning course, taking a user interface design course. I took machine learning. I've never touched machine learning after taking the class in college, but I think it's just valuable to know that stuff and be able to talk to people who work in that field, because odds are on the job, you'll end up working with people who are machine learning engineers, and it's good to have that context. Yeah, as I said, if you have solid data structures and algorithms knowledge, you're pretty well prepared for technical job interviews. So if you have that and like some portfolio of projects, you should be pretty good for the interviews themselves, but that doesn't mean the other classes aren't worth taking. And I guess I mentioned this before, but I would not worry about learning a bunch of different languages, because you're going to learn them on the job as you're needed. I would just focus on becoming familiar with a couple, which you will be through school. Like, I'm sure you're using 1 or 2 languages for most of your classes. Once you're comfortable with those, it'll be very easy to pick up new ones. So I guess when I was in college, there was a lot of friends around me who were like, oh, I got to learn this language, have more languages to put on your resume. Doesn't really matter for the most part. Unless you're trying to work for like a startup that has like a specific need, for the most part, companies don't really care. So I would just definitely focus on having those strong fundamentals. And with that, that's all I had for you today. So thank you all for your time. Super happy to be here. And I do have like some extra time, like 15, 20 minutes. So if we can open the floor for any questions.
Great. Thanks so much, Kenny, for this session. You know, in your opinion, you thought you probably were repeating much from the last time, but trust me, having listened to you, I can pinpoint certain areas you've highlighted which you did not include in the past one, which has made this session a unique one on its own, and that is awesome. Before I even make any input or suggestions to the students, we'll give them the platform to ask their questions. So I've as I've always been telling you, when I'm engaging with you, you can't keep your cameras turned off, so that we can personalize the response. So if you're going to ask a question, first and foremost, use the reaction feature, and then I'll call out your name. And then when you are given the opportunity to ask your question, please turn on your camera so that we know who we are discussing, who is really asking the question, and who we are sending the response to. It may be informative to the rest of the class, but regardless, since you are asking the question, let us know who is asking the question, and then we proceed from there. So currently we have 2 hands up. I'll begin with Alfred. Alfred, you can go ahead and unmute yourself and then ask your question.
Hello, sir. Please, considering the life cycle of the software engineering, combining these things, and then maybe from development to testing and then maintaining all these softwares, how does he handle the pressure that comes with it?
How do I handle the pressure that comes with like going through the typical software workflow?
Exactly. Yes, how do you handle the pressure? Yes.
Yeah, that's a good question. It's definitely, it's definitely a lot of work. I think there's a couple of things, and I'll try not to ramble, but I think one thing that I've had to learn since starting work is that you're never really done with work, right? Like when you're in school, when you finish a homework assignment, like you're done, you don't have to worry about it. When you're working, if you finish like a project, you're gonna get a new project. Like they're not just gonna let you sit there and do nothing. So part of your mindset, which was a struggle for me at first when I started working, is you have to get used to the fact that you're not gonna finish things immediately. and you have to kind of like know when to stop each day and continue, like get into that balance. Another big thing is I think it's important to rely on your team and to find a good team to work for. I think I really like the team that I work for because all my teammates work together. If I ever need help on my project, I can have people on my team help me with that. Actually, one of my teammates was working on a very big project maybe in like March and April, and she wasn't really going to meet her deadline just because it was a lot more complicated than she thought it would be. So it's not really her fault. So what my manager did was she pulled some of us away from our own projects. So she basically said, yeah, the project that you're working on, you can just put that on hold for now. Why don't you help her with her project for now? And that'll be your priority for this month. So I think it's really on your manager too, to see how everyone's projects are going and decide how to allocate the people on your team to do that. So that was a really big help to her. And I learned a lot from helping her as well. I think the other thing within the workplace is that deadlines tend to be more flexible depending on the team you're on. For my team, at least, YouTube ads, there's not really super fixed deadlines. So it's like, if we don't finish something within the goal, which maybe is like, we want to finish this by June, but we don't finish it, it's usually okay to like extend the deadline a little if you just talk to your manager. Because usually it's not your fault if you don't finish something. Usually it's because something more complicated come up. But of course, this depends on your team. Like, I had a friend who's working at Apple, and I think they had to launch the iPhone in October or something. So before that, like that's a very important deadline. If you don't meet that deadline, you can't just delay it. So that's a very different circumstance from the team that I'm working on. So that part definitely depends. Yeah. Sorry, does that answer your question? There's a lot of.
I think, Alfred, are you satisfied?
Yes.
With the response?
Yes, please.
Great. Well, I can actually add a bit to this response. You know, I worked with a team when I was in the corporate world. I had a software development team under my belt, and as I was transitioning back to the academia, I did my best to give each one of them the opportunity to land a remote job, and thankfully most of them, in fact, except one. In fact, he was so excited to land this job. I don't know, it was a US company, and their deadlines were quite tight, and they had huge expectations, having succeeded, gotten through the technical interviews and everything. Unfortunately for him, he was thinking probably he was going to have a flexible deadline. He was going to work 8 hours wherever he had gotten to. He would pause. They wouldn't demand so much from him. And in less than 24 hours, they nearly sent him a query. And in 72 hours, he called back and told me that, Mark, you know what? I have quit that job. He couldn't keep up. He couldn't keep up because he's not used to that kind of routine. And his other counterparts went through quite similar situation, but then they understood the demands. You know, the work environment varies slightly. But these guys, the other guys who took in the pressure, and they succeeded at it, at least the first couple of months during their probationary period. They ended up, winning the confidence of the employers and having much more flexible deadlines to complete tasks, especially when they were graduating from being team members to team leads here and there. So yeah, like you're rightly saying, it will depend on the team you find yourself and the project manager.
Yeah.
I'm pretty sure even within Google, there could be some teams whose deadlines are hard pressing, especially when Google I/O is approaching and they want a product to be out there, to be showcased, and is the main focus of the CEO. And you have to make sure these things happen. So I think the team you form part of and the projects you are working on largely will influence some of these hard deadlines that you would have to meet. But yeah, I guess your case, like you have indicated, is quite flexible. Okay, David, you are next. You are up. What is your question? I see only 8 hands up. I guess that will be all the hands that would want to ask questions. So please don't add yourself. Oh, gee, they are all adding their numbers. Please, can you make it quite brief? You have not more than 20 minutes. We've already exhausted some.
Okay, proceed. I'll also keep my answer shorter.
Hello, sir.
Yes, proceed.
So I wanted to ask, how do you set yourself up to complete projects? Like, is there a management tool you would use personally, or like you would use the one given to you? I mean, the task given to you by your project manager, and you know, how exactly do you go about the process? Because you've been given a task in general, but you breaking it down and all that, is there something you would do? And also, if you're a team lead, what processes would you use to motivate and move your people to complete the task?
Yeah, I guess I can speak more for the first part because I'm not a team lead, so I haven't really experienced that. But as far as how do I go about solving a project that I've been giving, I think at the beginning, at least, the most important part is to ask a lot of questions and ask good questions. So whenever I'm giving a project, the first thing I do is try to understand as much of it as I can. And there's going to be a lot of it that I don't understand. Like I feel like I'm very often confused. The best thing you can do is just be organized about that confusion. Like, here's what I understand. Here are the parts that don't make sense or we need to discuss in more detail. And on top of that, for the parts that you have confusion about, either coming up with very good questions or basically try to make it easy for people to help you. Like if there's a part that you're not sure about, maybe you could propose some ideas. And that's a good way to start conversation with other people on your team. Because if you just say, hey, like, I have this problem, I'm confused, can you help me? Like they're not really gonna know what to say. But if you say like, I have this problem, I'm confused, here's some ideas that I'm thinking, well, what do you think about that? It's a lot easier for them to give input. So I'm always confused when I start projects. Best thing I do, I think, is just be organized about the questions I have and get help from your teammates, get input. Yeah.
Okay, so like just a follow-up question. Do you give up when your personal project is dragging in terms of time? Do you set a time frame for yourself, or you give up if you are not getting solutions so that you can jump onto another task? Is it a personal decision, or probably you use some particular tools like Trello to guide your projects, personal projects? Kenny, I don't know whether you get my question. Just a follow-up.
Yeah. Yeah, we definitely have like tools we use to like track progress of our projects. Definitely we don't give up when we get stuck. I think usually what I'll do is I'll like ask people for input on a specific problem, and you might have to wait a little bit for them to get like a response, and there's some back and forth discussion. But I think it's important to always like have questions out waiting for responses. Like I never want to be in a place where I'm just sitting there alone feeling like, oh, I'm stuck. I'd rather be in a position where I'm sitting there waiting for someone to give me input on something I've come up with. So I think that's how you just always keep it moving. Like as soon as someone gets an answer back to you, you think about, oh, how can I like take their answer, figure out as much as I can, and then send a question back to them so that they can help me. So yeah, it's always about like, how do you unblock yourself, I guess.
Nice one. Okay, I guess my question answered. You responded to somebody's question in the process, so we'll proceed on to Nana Obeng. Nana Obeng, can you make it quick? You are hearing some Ghanaian names, Kenny. Nana Obeng.
Yeah. So implicitly in your presentation, you made mention of things relating to design thinking and using the lean methodology. So I wanted to know if it's a requisite for a software engineer to know all these things before you enter into the software engineering industry.
Yeah. So you mean about like designing specifically, right?
Yeah.
Yeah, I'll be honest, when I started at Google, I didn't really know much about designing stuff. Like I wasn't very familiar with structured ways of designing. I feel like you learn a lot of that on the job. Like here's how to write a proper design document. So like when I started, what I would do is given a project, I would just try to write notes on what I understand and didn't, and write as much detail as possible and get people's input on that. And I think over time, depending on the company you work for, you'll learn like what's the preferred way of organizing your thoughts. So I wouldn't worry too much about knowing a specific format or way of designing. I think it's more just about building good habits. Like if you're generally like organized about problem solving, if you're able to be organized about the questions you have and what you understand, you'll be able to learn any type of design process because those skills are what's needed for all of them. But yeah, that's a good question.
Great. I hope he has answered your question, Nana, well enough.
Yeah.
So let's
Yeah.
move on to Said. Said, you are up next.
Hello, sir.
Yes,
Hello,
proceed.
sir.
Proceed already.
Actually, I wanted to ask
Yep.
2 questions, but one has already been asked by David. So my next question is, how relevant is data science to software engineering?
Yeah. So the question is, how relevant is data science to software engineering? Yeah, I think a lot of the answers I'm going to say are all like, it depends. And for data science, I
Agree.
think it depends on the size of the company you work for and what's asked of your role. If you're at a company like Google, Amazon, huge companies, they have separate positions for like data science engineers and software engineers. So as a pure software engineer, you're probably not going to need too much data science knowledge. You might be like a software engineer working on a data pipeline that data scientists use, but you're probably not going to be asked to do like, I don't know, data cleanup, modeling as a software engineer, probably. If you're at a smaller startup and they don't have as many engineers, you might be asked to do a bit of everything. So it really depends. And also depends on your preference. Like some people like being at a startup where they get to do a little bit of everything. Some people just want to focus on what their job role entails. So sorry to give the same answer, but it really depends. But you definitely don't need it, I think.
Yes. Yeah, I couldn't agree any differently. It's a different branch of computer science. So it's either you're a software engineer or you're a data scientist. It's not even encouraging to combine both. So yeah. Okay. Nutifafa Afi, is that a lady or is a guy? No lady has asked the question yet. The numbers are reducing. Let's do this quickly. Ato, can you?
Good evening. My question is, you mentioned earlier that there are a lot of resources on the internet and specifically YouTube. So I wanted to know how do you think students can make the most of project-based tutorials on YouTube?
Sorry, what was the question about? I heard project-based tutorials on YouTube.
I was asking that how do you think students can make the most of project-based tutorials on YouTube?
Okay, yeah, that's a good question. So the question is, how can students make the most of project-based tutorials on YouTube? So I actually haven't used too many resources from YouTube directly. When I was building, like in high school, when I was building my website project, I was looking up like other websites, like HTML tutorials. So not for a specific project, but how to use HTML, how to learn JavaScript. So I think there's 2 ways you can kind of approach it. I know on YouTube, there's a lot of tutorials like how to build this specific thing using these technologies. I think those are useful, but the risk that you have when you do it is you'll just end up copying what the tutorial does. Like the tutorial will say like, here's how you code this thing to achieve this thing, and then you just copy it over. There's not too much value in that. Like maybe if it's your first time using that specific technology, it's a nice way to learn. But other than that, you're mostly just like copying from that. I think a more useful way to use tutorials online is to use more general tutorials, like how a specific language works or similar examples, and then use those in your own creative way to make something new. Like in my case, I use HTML and JavaScript tutorials online, which aren't really to build anything specific. And I tried to use those tools to build like the website that I needed to make. So I feel like that is probably a more valuable way to use online tutorials. And it also helps you build very cool like personal projects. Yeah, hope that answers your question.
Yeah, I hope it answers your question, Ato. Okay, Raphael, you are up. Raphael Ajite. Yes. I think Alex Benjamin already put out his question, so that I've seen it. Someone wants to impose his.
Yeah, hello.
Yes, all right, Raphael, you're on the floor.
Yeah, hello.
Yes, we can hear you. Ask your question. Ask your question. We can hear you, Raphael.
Hello. Yeah, we can hear you.
Yeah, hello.
Yes, we
Hello?
can hear you. Go ahead. Go ahead. We can hear you. Go ahead. We can hear you. Okay. I think he's having trouble hearing us, though we can hear him. So we'll move on to the next person. John Jelima.
Yes,
Can you
sir.
take over? Yes, we can hear you. Do you want to go ahead?
Yeah, I want to go ahead now.
Please, go ahead and ask your question. Yes.
Yeah, I know companies like Google and some other tech companies, their main goal is to make products not only marketable but technically good. So, and the other like stakeholders, maybe non-technical people that will have to interfere in your decision as a software engineer. Maybe you are a perfectionist. You have to. There's a certain way you want to do things, but there's some other technical guys, non-technical guys that want to change things to suit, maybe to make more money, to make it more marketable. So what are some of the issues you find or you encounter as a software engineer based on that? And how do you come like to bring a middle ground for like everybody, like a win-win situation for everybody to be happy, both stakeholders, people at the board meetings, and so to come out with a good product that is marketable and make money and it's also technically good.
Yeah. So that's a very good question. And I unfortunately don't have too much insight to that question, just because at a big company like Google, like what you talked about, these big, like, I guess, non-technical product driven decisions happen at a very, very high level. Like, I don't know, CEO, or it's probably the like VP level. So the VPs are like the heads of each department, like ads, Google Maps, Google Search. The VPs are probably the ones making these like big product decisions. And then all the people directly under them will think about, okay, how does this decision affect my specific like sub team? And the decision kind of trickles down. So at the manager level, it'll probably be like, okay, we need to like build this specific thing to achieve the product goal that the VP set. How can my engineers work on projects that achieve this goal, that fit that product goal? So at my level, the engineering level, I don't really worry too much about those big picture product decisions. Just because that's something my manager worries about with his manager, and she worries about with her director, and the director worries about with the VP. And I think it's probably good for like the lower level engineers like myself to have an understanding of those decisions, which is communicated to us through like emails and like presentations. So we understand those decisions, but we don't actually have to like make them, just because those are very high level decisions. So yeah, sorry, I couldn't give a more helpful answer, but that's how it works at a big company, I guess.
Yeah, you done your bit. Actually, I think I understand where Raphael is coming from. You know, I mean, I'm interfacing with some guys, my past students who are also engineers working for remote companies here and there. And there's one project one of these guys was working on. It's been outsourced. It's actually a Nigerian telco service that has outsourced the project to the recruiter, and the recruiter has passed this job on to this guy. And he's on quite a similar project with the Ghana branch of the same telco service. But in the engagement with the Nigerian counterparts, you know, there is a lot of coherence, misunderstanding here and there. You know, sometimes when you think this is the right approach, when he cautions them that when we deploy this and we don't test, etc., this is likely to happen. They don't want to budge. He endured for almost a year, but I got to a point they wouldn't listen, and he resigned from that branch of the job because, you know, we can't deploy a solution and in a space of just 1 hour, whatever he anticipated was going to happen, number of crashes, time, server incapacity. I mean, some of the occasions the servers were not able to handle the number of requests within that short period. Like in Kenny's case, they said 0.1% of users before they even expand the numbers gradually. The Nigerian branch were not ready to listen to such advice because they are paying you to get a job done. So that kind of misunderstanding may occur. You try to reason. If it doesn't work out, there's very little you can do. You probably have to manage the source of your income if you so much need it, or you probably take a decision that will be in your favor. But that is bound to happen, especially in this part of our world. But of course, in the FANG, I believe they really understand the processes and specialization where people can focus on specific tasks and roles. So the people at the top will have to worry about what they have to worry, their directors, and then we down there also have to worry to extent what we can do. As he mentioned, the most difficult task is from putting together your requirements engineering, how the solution will look like, etc. But once all of that is done, the coding bit, everybody wish that's just all they will have to do. Everything is detailed for them, and they all have to sit down and just implement the codes. The design is already done for them. So the situation may vary. So I suppose when you encounter this within this ongoing project or outside here, you'll figure a way out. We have just a few more hands. So we'll move on to Jilma. Jilma, can you make it quick and snappy for me? Jilma John.
Hello, sir.
Jelima. Yes.
Hello, sir. Can you hear me?
Snappy.
Yes,
we can hear you.
All right. Okay. My question is, what advice do you have for a career planning and advancement like me? If you were me, what will you do? What will you go into? And again,
he's not you. Wait, he's not you. He doesn't know your aspirations, so I don't understand what you're saying.
I mean, what I'm asking is like at my level, what will he go into? Like as a computer science student. I don't know whether I get
software engineering, knowing a whole lot of programming. Well,
yes, please.
He's told you his story.
Like, I mean, like, what advice will he have? Will he have for me?
Okay, advice
at my level.
Okay.
Yes, something like yes.
Advice, fine, but what would you do? I mean, he told you what he did. Okay, Kenny, if you do you have any advice for a software engineering student aspiring for, an unknown position in the field?
Yeah, I think some of the advice I already outlined in my presentation. Like, I think working on personal projects is a very useful thing to do. I think one thing that's valuable is if you're not sure what specific field or industry you want to go to in software engineering, it's valuable to try to take different types of CS courses at school if they're available, just because it's a nice way to kind of sample different fields. Maybe you'll take a data science course or something and find out you like that more than back-end engineering. And that's valuable knowledge for you to learn in college, just because you have access to those resources. So if you're unsure about that, I would definitely recommend, or either way, I'd recommend taking lots of different types of classes. Working on personal projects is great, and really just building up your fundamental skills, making sure you have strong data structures knowledge, because that's going to be useful no matter where you go in the software engineering world.
Yeah, I think you've made a good point there. I'll just make an insight here. The students, in your presentation, you highlighted this. Do not waste your internship period. My students here, some of them have the habit of going to sit in banks and becoming front desk attendants, fixing people's network, helping them to print their stuff on their PCs, and they are computer science students. They don't choose fields that will help them improve and add value to themselves. Kenny has just advised you. You need to build your projects on your CV, your portfolio. So this should inform your decision, because internship is compulsory for you guys this particular semester. So choose wisely. Right. So we'll go on to Donko or Xiaman. Can you make it quick? I'm not pronouncing your name well, I suppose, but even if I'm here and I'm struggling to pronounce your name, how more Kenny? Xiaman, is that the name?
Yes, sir, Shamai. Thank you very much for the question. The opportunity, sir.
The opportunity. It's no problem.
Yeah. Mr. Kenny, please, as a software engineer, how do you manage stress and pressure?
Okay. Yeah. So, of course, how do you manage stress and pressure? I think one great thing about working at Google is that they really emphasize having a good work-life balance, which is definitely something I really appreciate, and it's not the case at every company. So that's something I'm definitely grateful for. I feel like the culture at Google, to begin with, is very good. like the managers are always very encouraging about like work-life balance. So I feel like given that sort of culture, it's a lot easier to maintain your stress. I mean, still get stressed sometimes. I think one useful thing that I do is I just try to disconnect from work a certain amount every day. And I guess I have the like opportunity to do that, but I think it's just nice sometimes to be able to disconnect a little bit, fully take time off if you need it. Yeah, I don't know. This answer is a little hard to answer because I feel like the
Yes,
company as a
I can
whole does
agree.
a really good job encouraging that. But I know that's not always the case for people in the software engineering field. And I guess, like, yeah, I don't know. Sorry, I don't have a great
Yeah, I
answer
mean,
for this question.
yeah, there is no one-stop shop answer response to this particular one. And it's actually time you've taken off from your busy schedule to even engage with us this time, just to flash work off your mind for a moment. So it's quite valuable. So we need to learn how to manage that. I mean, I don't think there's any one of my students who is currently in the position to tell me he or she is under such pressure as you're anticipating. But I'm pretty sure when you get there, you'll be able to navigate easily. Jeffrey Dankwa, can you ask your question? Jeffrey. If Inshira Swansea, you are up next. If Jeffrey is not ready, we don't have much time. Whichever one of you is available? Yes, Inshira. Inshira, proceed.
Please, I wanted to ask if there is any basic or fundamental skill we need to know before entering the job.
Oh, I
Sorry,
think I'll
could you repeat that?
overrule this question because he's already highlighted this in so many ways in his earlier presentation. So maybe I'll help you with a recap on that later. Jeffrey, can you ask your question?
Yeah. Good evening, Ken.
Yes.
So my
Proceed.
question is more of experience. So my question is maybe your first day at work and then maybe subsequent days are followed by maybe you're given a project to work on with your team. So maybe in your team you saw that maybe this guy or this person is more experienced than you are, his code is much efficient and all of that. Were you intimidated by it? Yeah, that's my question.
Yeah, yeah, definitely. When I first started, I was working closely with someone on my team who was basically mentoring me. So she knew how the team works, how the technology works, how Google works. And it's definitely intimidating being on a team where everyone just seems like they know so much and you're the new person and everything is confusing. You don't understand anything. And I think everyone feels that to some extent, and it's a normal feeling. And the best you could do is just move forward and accept that, you know, over time, you'll learn more things. I don't know that in my 2 years there, I don't know that I've necessarily gotten like I still feel that way sometimes, but just by being there for 2 years, I've learned so much about my team, how it works. And like, I think it's also important to take a step back sometimes and just look back and see, wow, this is how I was at the beginning. This is how I am now. Even though I still feel confused all the time, we've actually learned a lot along the way. So yeah, I guess to answer your question, definitely normal to feel intimidated. But I think that's also a great opportunity for growth.
Yeah. So thank you for that response. Okay, so Joseph Ampedu, we have just about 3 more hands to go. Can you ask your question, Joseph? Joseph is not ready. Can we move on to the last but one? No, those of you raising your hand, I won't let you ask your question. Kofi Ando, Silas. Kofi. Okay, so I guess.
Hello, good evening.
The last. Yes, Kofi, make it quick.
Okay.
I think you're the last person.
This Kofi Ando. Yeah. Please wanted to ask Mr. Kenny why he chose to become a software engineer and some mistakes he learned from the software engineering field.
So I got the first part. Why did I become a software engineer? What was the second part?
The questions are in two folds. Why you decided to become a software engineer?
Okay. Yeah,
And then
so I
what
guess for
else? Can you ask all of them at once?
And why some lessons or mistakes you learned from the software engineering field when you decided to venture into it?
Okay, yeah. So for why I became a software engineer, I feel like, I mean, for one, growing up in the Bay Area, first of all, there's tons of software engineers. Like many of my friends' parents were software engineers. So we're just exposed to it at a young age. Not that we coded from a young age, but you see software engineers all the time. So I think in all of our minds, it's like a very realistic possibility. But I guess on a more personal level, I just enjoyed building things. Like from my presentation, I talked about how in high school, I kind of got started teaching myself how to build websites and stuff. I just found that experience really enjoyable. Like I enjoyed creating things that didn't exist before, building something from scratch that other people could use. I found that experience really rewarding. I think I enjoyed doing that more than taking most of my classes in high school. Like, I don't know, science and physics and math classes were cool, but I enjoyed building things and like creating things with code. So it was a pretty easy decision for me to want to go into software engineering given that. Obviously, yeah, so for mistakes that I've made and lessons I've learned, yeah, I need to think about it, but definitely learned a lot in the past year. I feel like one thing early on that I've definitely learned now is when I first joined, I was hesitant sometimes to ask for help. Like I felt like I'd be annoying people on my team who knew so much and I didn't really know any. So I'd be hesitant to ask for help sometimes. Or if I ran into a difficult problem, I'd just try to stare at it for like hours and not figure it out and only then ask for help. And I've since realized that, especially as someone who's new to a company, I mean, maybe depends on the company as well, but shouldn't be afraid to ask questions. And the best thing you can do is to kind of make sure you've tried to answer your own questions. And if you can't find the answer, I think it's fine to ask for help. And that's a very important part to learning. I think it's valuable to be in a work environment where asking questions is encouraged and is seen as a good way to learn because it's kind of necessary. There's no way around it. So if I could go back, I would tell myself, don't be so afraid to ask questions. And also don't feel so intimidated by the people around you because you're all going through like this software engineering journey together. Some are just a couple steps ahead and some are a couple steps behind, depending on where you are in your careers.
Great. We can't thank you enough. I think I will overrule any more questions that may be intended towards your direction. Just a handful I'll pass on here. Some students are trying to figure out how you managed your hackathons, the competitions, whilst you were a student, and still managed to focus on your academics and pass out well. And I think somebody is also interested to know why you didn't consider ever quitting. What was your motivation to keep up in the college life as a computer science student? I think the answers to these two questions may be enough to wrap up the session.
Okay, cool. So I guess the first one was how do I balance like other activities like hackathons and stuff with schoolwork?
Yes.
And I guess this extends to pretty much everything like personal projects, preparing for interviews. These are all things you may have to balance with schoolwork. I don't really know how like the school system works, but I guess one thing that I would do here in high school and college is taking advantage of the summers where we don't have classes. So you'll have class for like 9 out of 12 months of the year and then like a 3-month summer break. During the summer break, a lot of students will try to find internships, but it's not always possible early on. And I think it's good to take advantage of the free time you have. Like if you're working, like if you have time where you're away from classes, it would be nice to like spend a little bit of time working on a personal project. And the cool thing about personal projects and hackathons is they don't take much time to do, especially a hackathon. If you think about it, at least the hackathons I went to, it's usually just like 24 to 48 hours. So if you really focus for a very short amount of time, you can have a project that you can put on your resume. So I feel like that was very good motivation for me. Like if I can just set aside 24 to 48 hours and really try to build out this project, it could potentially be something I could put on my resume. So it's like, I don't know, short-term effort for a pretty long-term reward, because it's something you could use for a long time. I guess it can be a little difficult to do when you're also trying to balance classes. I think the best advice I can give for that is, if your classes are very difficult, obviously it's not always possible. But the best thing I did was try to treat like studying for interviews, especially, as like a separate class on its own. Like maybe just spend 1 hour a day doing like one practice interview problem each day, which might not feel like much, or even 1 or 2 per week. It may not feel like much, but if you do it for a year, you'll be done with like 100 or 200 problems. And that is very good practice. So anything you can do to like fit it into your daily schedule is a good way to think about it. Same with personal projects, like work on something a little bit every day. Like maybe one day build a menu bar for your website and that's it. The next day build a single like feature and that's it. Anything you can think of to like break it up into more manageable chunks will help out. And sometimes it's not possible. Sometimes you're just too busy, and that's fine. I guess, sorry, could you remind me the other question?
I think you've answered all of them, quite frankly.
Okay.
I mean, I think the last question was why you didn't give up. You know, you had built sufficient skill set to, and now that you are even mentioning it, you have, you had taken some, you had prepared yourself for technical interviews, one form or the other. So why did you spend all the time in the college to just complete regardless and not quitting like Zuckerberg or Bill Gates, who all dropped out of college?
Yeah, I mean, I guess I continued because I was just close to finishing and on a good track, you know, like if you're close to finishing, and finishing will give you just that added layer of like job security, make it easier for you to find a software engineering job. At that point, like you've gone through so much college that you have all the technical skills. You just need to refine them a little to like, you're at the last step. You've gone through like the hardest part of taking half your classes, learning these things. So I feel like in my mind, it was just, I've already gone through like so much of it. I have the skills I need. I just need to put in a little bit of effort to like study a little bit for interviews, prepare a little bit. And with that little bit of effort, you can get like a very like nice software engineering job or something. So I feel like for me, I never really thought too much about it because that was the mindset. Like you've put in so much work to get here. You have so many of the skills needed already. It makes sense to put in that little bit of extra effort to just like acquire the final amount of skills you need to take that last step. So yeah, I definitely encourage all of you to push through, no matter how hard it feels now. I believe that you can do it, and I don't know, it's good motivation.
Yeah. Yeah, we can't thank you enough. There are a couple of questions, but I think those asking the questions either did not get the import of your presentation at those points because you've already made mention of that. I mean, if I'm not wrong, your team is set up not to fail, because even when you have to introduce a new function, you have various levels of approvals, even before you get to deploy, and even during the deployment phases, you have a few selected number of people you target before you even expand all of this. So I think it sets you, regardless that have there been occasions where there still have been situations where the project just wouldn't succeed? Have you encountered that
all
since
the
you
time.
joined? It happens all the time.
But I think what you said is very important though. Like Google's philosophy is to set you up to not fail. So it's always like, if anything ever breaks, it's never the engineer's fault who broke it. Like it's like part of the culture to never blame the engineers. It's always to blame the system. Like if someone causes a bug that breaks the system, it's not the engineer's fault. It's why didn't our tests catch it? Like why didn't like the review process catch this? How did it get through? And how can we improve the system to catch it for everyone in the future? So I think that's a very good philosophy to have, and it takes pressure off individuals and basically brings everyone together to work on helping others not fail. Of course, sometimes things do fail. Like we do have breakages sometimes that result in losses of millions of dollars. They do happen from time to time. And I think Google still goes by that philosophy. Like when these breakages happen, you have to find out who's responsible. It's not like you don't blame that person, but they should take responsibility for suggesting how can we avoid this in the future. I feel like that's, I guess, a pretty diplomatic approach to this, but I think it's a good philosophy, and it helps others, not be afraid to like do things.
It's interesting how things work out there. In this part of our world, sentiments are huge barrier. But well, we'll get there when we get to that bridge. We'll definitely cross it. We can't thank you enough once again. We need a lady to volunteer to, show some appreciation to Kenny for the time he's devoted with us. Yes, well beyond an hour and a half, and he's still here with us. Originally, we planned to make this happen in 1 hour. So I would want, only about 3 ladies have asked questions, including the Enshira. Can we get a volunteer from amongst you to, on our behalf, express our gratitude to Kenny? Any lady amongst you guys over there? Enshira, I can still see your name here. So can you unmute yourself and then, oh, okay, somebody nearly unmuted herself. Yes, who is there? Where is our volunteer? Who is stepping up? Don't disgrace me.
I'll do it.
Proceed, yes. Yes, so we are listening. Harriet.
Okay. Sir.
Yes.
Mr. Kenny, on behalf of my course mates and our dear lecturer, we want to thank you very much from the bottom of our hearts. Thank you for the impactful words. Thank you for the information. Thank you for the motivation, because I think some of us didn't know the usefulness of studying software engineering until you highlighted everything into details for us. Thank you very much, and God richly bless you. And we pray that whatever you set your mind on will become successful. Thank you very much, Mr. Kenny. It was a pleasure having you. Thank you very much.
Thank you so much. It means a lot.
Yes, we are really grateful on my personal behalf. In fact, she said it all. It's not like I did not mention some of these things, but my teaching methods are all influenced by opportunities that I missed. And I'm happy I have the likes of you to always avail yourself to be available to my students. So it makes a whole lot of sense to them now. It will help them think differently about the projects they are embarking on right now, commit to it, not because of grades, but obviously to, build up their own CVs and set them up for success in the long run. And I believe many of them who have yet to do internships will take advantage of the information they have received to make the right decisions and join the right institutions that will help them grow. And even if you don't get to intern with a company, you will know what to do with your valuable vacation instead of thinking of folding your arms and sleeping away the several months. You would rather invest the time into building up your skill sets and especially nailing these data structures and algorithms. In fact, all the guys who interviewed with Google, it seemed to be the only thing they asked them to prepare for: discrete mathematics and data structures. Yes, this is all they're interested in. They don't care which programming language you are proficient in, just prepare for these two. And that is where the shortfall is. And this will form key to the projects you are equally working on. Once again, we are grateful for your time, Kenny. And of course, we will continue to keep the conversation door opened. We thank you for your time. Thank you guys for engaging. I'm leaving a link in the chat section of these teams, guys. It's exclusively for you, the students. You don't want to miss it. You would want to act on it as soon as possible. Thank you once again. And Kenny, please have a good day, and we'll connect sometime soon again.
Yeah, sounds good. Thank you so much, Mark.
Thank you, sir. Thank you, sir.
You're most welcome, guys. Get on with my projects.
Thank you, sir.
People engaging. Enjoy the rest of your evening, guys.
Thank you.
All right.
Bye.
Bye.
Thank you.
Bye.
Thank you.
Bye-bye. Hello, sir. Thank you, sir.
Thank you.
Bye.
Bye.